Hi all, my name is Trent Carter and I'm sitting here with Gabriel board
Great.
designer at Slingshot Sports, and we're going to kind of talk through the construction of the new Project Drag board. Gabe, pleasure to have you.
Thanks for having me.
My first question for you is, why is layup important on boards? There's so much focus spent on the foils, everything
Yeah.
below the water, but people kind of tend to forget about what's going on up top. So can you walk us through what makes the layup and construction of a board so important
Yeah, yeah.
for all the factors?
Yeah, so I would say layup is half of what will make a board work or not work for someone. Half of that is the shape component, and we'll talk about that in a minute. But the layup is what will give the board its weight, its stiffness, and its durability. And those are kind of three levers you can pull. When you bring one up, the other one goes down, of course. And then you can work with different materials to be able to push as many levers up as you want. So the weight side of it is self-explanatory. If you can reduce your resin and composite use or your sandwich material use, you're going to drop the weight, but you're also going to decrease the stiffness and durability. Stiffness comes from um, the material choices you make. You can have stiffer materials, but they're more brittle. You can have slightly softer materials, but they're tougher. They can take an impact better. And the weight um, just is determined by how much reinforcement you need. Is this a beginner board that's going to sit in a school parking lot for years and be tossed by beginners in and out of the water? Or is it something that a racer needs to ride for one season and have, take very good care of it, race it for a year, and then move on to the next one? So somewhere in that spectrum is where we need to choose and land for any given board.
Excellent. So you told us that you've been working on this layup for this board for the last couple of years. Can you
Mhm.
talk us through the evolution of that and what things you're really trying to maximize in that process? You kind of already touched on it, but what makes this layup so different or special
Yeah.
compared to previous layups Slingshot has used?
Yes, this layup was interesting because while we did optimize it for all these factors that we talked about, it was also a collaboration with the factories that we work with. And that's always an interesting component because I can design a layup at home and it takes me 10 days to put together, and then it's perfect. But if it's not viable for another factory to reproduce, either economically or just from a time perspective, it's not worth getting into. And so the layups in many boards, this type of board in particular, have what we call a sandwich construction. So we have a laminate, which will be some sort of a matrix, so the fiberglass or the carbon fiber, and then a binder. So you'll have your resin,
Mhm.
either PU or epoxy, in this case, epoxy. And usually to add strength to that and make some sort of beam, if you studied engineering, you know what I'm talking about. So if I can take my laminates and kind of spread them apart, the bending loads required to get them to move is a lot higher. So we need something lightweight, but very good in compression to put in between those two.
Mhm.
Um, in the boards, the past 10 years, not just Slingshot, but all the other brands, people have kind of gravitated towards PVC or to Vinicel, any closed cell foam. So you can have your low density core, some fiberglass or carbon. You put in your sandwich in there, so your 1 or 2 millimeter PVC foams. It's like a high density foam that's pretty stiff,
Mhm.
and you
Good
put
rebound, right?
yeah, good rebound, and then you put your other layer of carbon on top of that. So what that does is it allows it to be very stiff in bending, but also very good in compression. And so PVC has been an option. Bamboo sheets have been an option as well, very thin bamboo sheets. But they all have their downsides. The bamboo is relatively heavy for the thickness you get, and the PVC is super hard to work with to get to wrap around the rails. So the kind of labor required to get it in there is kind of hard. And so working with Tony at the time and with other people, we were trying to think what is another core material that we could bring into it. And we were digging around what is used in the pre-preg world, so kind of the aerospace world,
Mhm.
and honestly, going through the archives, what was used in the windsurfing world back 20 years ago. So it was a fun mix of super modern technologies and super old technologies.
What are the advantages of using this
Yeah,
material
yeah,
without kind of touching on too much secrecy?
yeah.
Like what does it give you that you were losing with bamboo
Yeah,
or that
so
high density foam?
so the weight and stiffness comes really close to that high density foam, which is really nice. you're talking around 180 to 220 grams per square meter per millimeter. So that's kind of the
Hmm.
thicknesses that are used. And what that does is you get the rigidity that you want, but when you buy it, it comes in rolls that are very pliable. And then you just kind of saturate them with a certain amount of resin.
Mm.
And so it allows them to put them in a single vacuum bag instead of 2 or 3 or 4 vacuum bag steps. I'm going to back it up and explain what a vacuum bag is. So when you build a board, to make sure that you are pulling as much unnecessary resin out of a laminate and any air out of the laminate as possible, you just want to make sure you're compressing it into the shape you want. So the way that we do that is we basically put the board in the plastic bag, make sure there's some substrate that will absorb any extra resin, and just pull a vacuum. And it kind of forms itself to the shape of the raw foam blank.
Awesome.
And this material, the cool thing that it allows you to do is it allows you to build the whole sandwich, top and bottom, in one layup. So you put your 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 kind of first layer of glass or carbon in this case, um, your sandwich construction, your outer layer of carbon, top and bottom, and then all goes in the bag. So that kind of reduces the amount of work needed by the factory, and it ensures that there's a perfect bond
Right, the
all
whole
around,
thing. You
and
don't
you're
have
not
any seams.
exactly, and you're not going to get weird wrinkles where you kind of have to bring the laminate from the top around to the bottom, and then when you put the bag on,
Yeah,
it kind of
yeah.
folds it. So it's a really cool process that we developed to be able to, yeah, bring a very high tech, high strength layup to a mass production scale, and we're pretty proud of that.
And without the crazy weight penalty, right?
Exactly, yeah, without the weight penalty.
Awesome. So how many variations in that development process did you go through before you landed
Ooh,
on this?
a lot.
Like in the order of like a dozen, 50?
I probably built personally 15 boards just in Hood River or North Bonneville, just kind of tinkering and trying out different densities. How much resin do we put in there? Can we do it in one bag, 2 bags? You know, what is the process for that? And then at the factory, probably another 20 boards.
Wow.
So yeah, 30, 40 boards. And all of these boards went on to be used for shape testing as well, right? I
Hmm.
was not just repeating the same shape. I was changing a bunch of variables. But yeah, I would say probably 30 to 40 different tweaks in where we place the reinforcement patches, how much resin we use, the bagging techniques, the kind of finishing techniques. So kind of touching on all those things.
Awesome. So on that note of where you place the reinforcement, I wanted to ask you, what are like the most structurally important parts of a board?
Yeah.
You see boards sometimes that someone ran into some reef or a rock and their whole fin box will pull out. You'll see like where they put their feet is all
Hmm.
sunken in, where they grab the rails is all compressed.
Yeah.
So if you could give us some insight on where you get the like where the most structurally important parts are, where you're really trying to maximize stiffness.
Yeah. Yeah. So foil boards in general, what you're trying to do is get your energy to the foil and control the foil's energy that's coming back to you. So all you really need is to find a way to make that load path super stiff. So where the foil connects to the board and where you connect to the board and how those two areas are linked,
Hmm.
that's where you need to get strength.
Maximum
Yeah,
stiffness right there.
maximum stiffness, maximum strength. Um, Anything outside of that load path, you want to you want to strengthen it as much as needed for any given use case. So, you know, longer, more beginner boards, people will grab them and then they hit the wind and it swings around and slams the doorway.
Hmm.
Right, so you do kind of need reinforcement in the nose.
Yeah.
But these boards, it's assumed that the people know what they're doing and they want to reduce all the weight around the edges so that it
Hmm.
can swing around more freely. So yeah, we're really focusing on reinforcing the connection from the foil to the rider. And that's achieved through reinforcement patches, so more carbon or more laminate underfoot or along the foil. How the foam connects, whether we use higher density foam or the same foam from the track or the box to the deck. So we have kind of solid stringers going up to the box. And then also how you're wrapping the rail, because there is still a fair bit of energy transfer going through the outside. So in this particular situation, the sandwich, instead of just protecting the feet and protecting the box, actually wraps all the way around the rail. So you get kind of that I-beam structure going all
Hmm.
the way around. adding the stiffness and also adding the strength. Say you take this board and you want to paddle it. If you're going to slam your paddle on the rail, it helps kind of absorb some of that
Yeah.
energy.
Awesome, Gabe. Well, that's all my questions I have for you. I'm going to pass the mic off to Edo, and he'll wrap it up.